Hey guys, welcome back to the channel. Today we'll be solving LeetCode 136 single number. So we're given a non-empty array of integers called nums, and every element in this array appears twice except for one, and we have to find what number that is. We have to implement the solution in the linear time, so O of n, and we have to use only constant extra space. So there's actually three ways to solve this, and I'm going to go over all three of them. And the most efficient one is going to have constant extra space, and the other two are going to have linear space. So let's get into the solution. So the first way we can solve this is using a hash table approach. So we're simply going to loop through, so we're going to have two for loops, and the first for loop is going to loop through the entire array and count the occurrence of each integer. So we're going to start at 4, and we're going to map the value 4 to the number 1 because we just count one occurrence. And then we're going to keep iterating. So we're going to move the iterator. Now we reached 1, so we're going to count one occurrence of 1. Then we're going to keep iterating. We reach 2, so we're going to count one occurrence of 2. And one occurrence, we're going to keep iterating. We reached 1, and we see that we already have 1 in the hash table. So we're going to update this to 1 plus 1, which is going to be 2. Then we're going to reach 2 and see we already have that in the hash table, and we're going to update it to 2. So now we can just do another for loop that just goes through each element in the hash table, and we can easily find out which one has an occurrence of 1. So in this case, we would see that 4 has an occurrence of 1, and we would return 4. The second way we can solve this is by using a set approach and using math. So we're going to convert this array to a set. So with a set, there would be 3 elements in the set. And the elements would be 4, 1, and 2. And then we're going to calculate the sum of the set. So we can do that down here. The sum of the set in this case would be 6 or 7. And the sum of the array, we're also going to calculate the sum of the array, which in this case is going to be 4 plus 1, 5, 7, 8, 10. So it'd be 10. And then what we're going to do is we're going to multiply the sum of the set by 2. So this would become 14. And then we're going to do the sum of the set minus the sum of the array, 14 minus 10. And this would give us 4. And then we know that the only element that appears once is 4. Okay, so the last two methods use a linear time complexity and a linear memory complexity, but we can do better than that, and we can get a constant memory complexity using bit manipulation. So the way we're going to do this is we're going to use the XOR operation in bit manipulation. So I'm just going to quickly go over what that is. So let's say we have the number 5. So this is 5, and um, we have the number 4, and if we XOR these two together, so XOR, or this symbol also represents XOR. If we XOR them, this would become 0, 0, and 1, because the way XOR works is only one, or every digit in the binary representation has to be different. So if two representations are the same, it would become 0. So in case one has to be 1 and the other has to be 0. So the only one that satisfies that is this. So this would become 1. And the reason this works is, think about this. Let's say we have two same numbers. So we have 4 and 4. If you XOR a number with itself, it's always going to be 0. But if you XOR a number with something else, it's not going to be 0. So to find out we can use this to find out which number only occurs once, because the numbers that occur twice are just going to cancel themselves out with each other. So let's do this with an example and iterate through this array. So we start with 4. So the binary representation of 4 is 100. And we're going to XOR that with 1. And that's going to become, this is the binary representation of 1. And that basically becomes, so these two become 1 because they are not the same. This is the same, so it's 0. This becomes 1. And then we're just going to keep going. We're going to XOR this with 2, which is 0, 1, 0. And that becomes 1, 1, 1. And we're going to XOR that with 1, which is 0, 0, 1. And that gives us 1, 1, 0. And then we're going to XOR the last one with 2. So and this is going to give us 1, 0, 0. And as you can see, 1, 0, 0 is the binary representation for 4. And we know our answer is 4, so we can just return 4. For the hash table approach, we can just initialize a dictionary or a hash table like this, and then we can loop through the array once to count the number of occurrences of each element. And we can do that like this. So for n, if n doesn't already exist in this dictionary, we can use this method so we don't get an error. So we can use the get method. So we get the element that has the key of n. And if it doesn't exist, if we can't find something, we're just going to put it at 0. And then we add 1. So what this is going to do is, if something doesn't already exist, it'll just initialize it to 0. And then we can just add 1 to it. And after we've counted the occurrence of each element, we can just loop over once again. And if the occurrence of each element is equal to 1, so like if it's equal to 1, then we can just return that element right away. We don't have to check anything else. And this will work because we're guaranteed a solution. So for the mathematical set approach, we can calculate the sum of the set like this. So we take the set of nums and then we calculate its sum, and then we multiply it by 2. So this is O of n, and this is also O of n. So we got the sum of the set, and then we're just going to take the sum of nums like this, and we can just return the difference between these two. So we can do the sum of the set minus the sum of nums. And sum of set needs to come first. This matters because it's larger. And this will just give us the number that only occurs once. Now, the last and most efficient approach, which has an O of n time complexity and a constant memory complexity, can be solved like this. And it's actually not a lot of code, but it can be hard to come up with if you've never heard of bit manipulation before. So we initialize a results variable to 0, And if you XOR anything with 0, you get the exact same number again, so that doesn't matter. And then we're just going to loop through the array nums, and we're going to XOR the result with the current number. So this is going to keep XORing with this result, and then we can just simply return it at the end. And this is barely any code at all, and it works, and it's pretty efficient.